The DDC platform is a versatile tool for managing building data and studying reuse strategies. It currently integrates 3 technical modules: 3D scans, reversible BIM, and materials inventory. However, it's designed to be easily extendable and connectable to other services. What's more, it's an open-source platform, so it's free to use and modify. First, a 3D scanning of the building is done, and based on AI algorithms, a first inventory can be generated automatically. Based on image recognition techniques, several types of building components like windows, doors, lightings, etc. can be detected. Then 3D scan and points of interest can be added to the DDC integrated platform. The 3D point cloud, the pictures, the POI and the documentation are used to create the building information model, and then the reversible BIM, including reuse potential information. The BIM is also used to generate the material inventory, extending the information generated with the 3D scan. Links between all these heterogeneous data are created. This goes to the material database to become the enriched inventory connected with both the 3D scan, the BIM, and RBIM. Finally, a dashboard consolidates economic and environmental indicators to support the analysis of reuse scenarios. Each building material or component in the inventory gets its material passport secured on the blockchain. Even if it's not currently supported by the DDC platform, the final idea is to make the contents available on materials marketplaces, where they can be purchased and reused. The DDC platform is also designed to be extensible and can be connected to other services. It's based on a database which communicates through a REST API with the backend and multiple module providers. This allows for easy integration of new services and providers, making the platform highly extendable. The DDC platform represents a new paradigm in building material management, one that is comprehensive, efficient, and sustainable.
Hello, my name is Kalin Boje. I'm a Research and Technology Associate at LIST, and I was directly involved in the development of the platform from the beginning of the project, including the system architecture, the data modeling part, and some parts of the front-end development. What I want to talk to you about is more on the front-end application or the web browser application, which was designed for the end users. Now, there are several types of end users that we designed for, starting with the client. The client is the owner of the project, so what he wants to see when he logs into the application on his browser is an overview of the project, such as documents, the 3D scan, the reversible BIM or the building information model, the information about his inventory of elements, the materials in the project, as well as statistics such as the reusability of its materials and volumes of materials involved in the project, everything to help him understand the project better and take decisions. All this is made available by the external module providers, which bring their data in via the backend services of the DDC platform. There are other types of end users as well. So, for example, if the client might hire a materials expert to help evaluate and consolidate the inventory of materials. So he can invite him on the project and assign him a role. So the materials expert might use a 3D scan, which is embedded directly into the dashboard, so he can navigate through the building and he can begin his work without having to visit physically the site, which makes it very convenient and also might increase his productivity when working on the project. And one of my favorite views on the front-end dashboard is the building information model view, because we've designed this to be directly connected to the inventory of elements. So when you start filtering your elements or selecting your elements, you can see them highlighted on your BIM model, and you can quickly go to the exact position of the element within the BIM model. And on top of this, with the reusability data from one of the module providers, we can color the model, the entire model or each element in its reusability colors, which makes it very convenient to identify elements which have a higher reuse potential, but also identify problematic elements. So with the BIM model, Although normally it's used for design and construction, it is very useful for a deconstruction case because you can find out more about the context of each element, what it is connected to, and it can really help your planning and logistics. In terms of technical development, the front-end web application was developed in Vue.js. It is a modern reactive web development framework. It is scalable, it has built-in security features, so it makes it easy to use, it makes it easy for future developers of this open source code to extend to their needs.
Hello, my name is Nico Mack. I'm a senior engineer at List, and in the context of the DDC project, I was mainly working on the backend of the platform. The backend is the server part of the application, and its main purpose consists in controlling access to the data handled by the platform through several web service methods. Its architecture follows a classic three-tier model, and it was developed using the Nest.js framework, a software framework specifically tailored for the design of web applications. So the first tier is called controller tier, and it exposes the API, which stands for Application Programming Interface, of the platform to the front end and the various technical modules connected to the platform. The controller tier is divided into multiple controllers, each controller handling one specific type of data managed by the platform. We used OpenAPI or Swagger to document the API, providing details about the parameters expected by each individual API route, as well as providing details about the results being returned. This greatly simplifies the work for developers wishing to integrate the platform, and it also allows to easily test the different methods just using a web browser. The second tier is called the service tier, and it actually implements the business logic of the platform. Just like the controller tier, this tier is divided into multiple services, each service handling one specific type of data, using exactly the same type of data that its counterpart in the controller part was handling. Last but not least, we have the persistence tier, which is in charge of reading and writing data required or provided by the service layer into the database. We use an ORM, Object Relational Model, abstraction layer to render the persistence layer agnostic of the type of database engine we're using, meaning we can easily replace the Postgres database we're currently using with a database from another manufacturer.